Hello, I'm Dr. Nagnath Hulle. In this video, we'll try to solve this problem. In this case, the statement is, for the circuit shown below, switch is in position 1 for a long time. The switch is shifted to the position 2 at t is equal to 0. Find the following. First point is, expression for voltage across the capacitor, which is Vc of t for t greater than 0. Variation between the Vc of t with respect to the time. And the last point is the current flowing through the capacitor and voltage across the resistor. Here we will decode this statement. When the switch is in position 1 for long time, this statement long time, it means the circuit was reached to the steady state when the switch was in the position number 1. Means here in this case, to solve this particular problem, we have to analyze this problem into the two parts. That is, behavior of the circuit for t greater than 0 and behavior of the circuit for t less than 0. First, we will start with behavior of the circuit for t less than 0, means before switching. This is the original figure. Before switching, the switch was in the position number 1 and the steady state was reached. During the steady state, this capacitor acts as an open circuit, which is shown here. Means in this case, if we are interested in the calculation of Vc of t before switching, that is for t less than 0, in that case Vc of 0 minus is equal to Vc of 0 plus, which is equal to same as the applied voltage, which is the 40 volt, which is this value. Whenever after switching is whenever the switch is shifted in the position number 2, in that case this 10 volt will be connected across this combination, which is shown something like this. In this case, there is existence of the source before switching as well as after switching. That's why the second condition after switching is known as a source driven RC circuit with initial condition, because we have the initial condition which is nothing but voltage across capacitor is the 40 volt and the existence of the source is there. That's why it is known as a source driven RC series circuit with initial condition. Now we'll try to solve each point one by one. Here in this case, first point is the expression for voltage Vc of t for t greater than 0. But as we are aware of, the expression for voltage for source driven RC series circuit with initial condition is given by the expression, that is Vc of t is equal to V minus in bracket V minus V naught into e raised power of minus t by tau. This is general expression. Means whenever source is existing and we have the initial condition, in that particular case we have this particular expression. This V is nothing but applied voltage after switching, which is 10 volt. This V naught is nothing but voltage available across the capacitor before switching, which is 40. And in this expression we will try to find out this tau. Now here in this particular case, this tau is nothing but RC, which is R is a 40 and the C is a 2 millifarad, that is 2 into 10 raised power of minus 3, which is equal to 82 into 10 raised power of minus 3 second is the time constant. Now here if we will substitute this value, in this particular case, this V is nothing but 10 volt, which is here, this minus sign as it is, this V is a 10 volt again, this is minus sign again, this V naught is the voltage before switching, which is 40 into e raised power of minus t by tau, and tau is nothing but this value, which is 80 into 10 raised power of minus 3. That's why if we will simplify this expression, in this case we will get 10 minus this subtraction is a minus 30 and we will get this particular expression. And finally the expression is the Vc of t is equal to 10 plus 30 into e raised power of minus t by tau, and tau is 80 into 10 raised power of minus 3. If we are looking at this expression carefully, how is the case? In this particular case, if we are assuming this t is equal to 0, means it will become e raised power of 0. E raised power of 0 is 1. 1 into this 30 means 30. 30 plus this 10 means 40. Means at t is equal to 0, we have the beginning, which is nothing but the 40 volt. And second case, if we have the t is equal to infinity, t is equal to infinity, in that particular case e raised power of minus infinity is 0. In that particular case, the minimum value available in that particular case at t is equal to infinity is the minimum value, which is nothing but the 10 volt, which is somewhere here. This is 40. This value is the 40 and this value may be the 10 volt. This here, the voltage across capacitor is going to discharge, something like this. I will analyze this discussion later on. But here, what is the case? I have written here. In this case, this V naught is greater than V. This V naught is greater than V. Means in this case, voltage before switching is greater than voltage after switching, because in this particular case before switching voltage is a 40 volt and after switching applied voltage is 10 volt. Means obviously there should be the discharging of the capacitor takes place, and the minimum value should be it reach to the 10, because already existing voltage across this capacitor is 10 volt. It should not be discharged below that particular value. Here in this case, if we are discussing this value, in this case V0 is greater than V, so then resultant equation is similar to the discharging of the capacitor, that is source free, because voltage before switching is higher value which is 40 and voltage after switching is nothing but 10 value, means capacitor will discharge from 40 volt to 10 volt. That is the point of discussion in this particular case. It is related to the point number 1. The second point is draw the variation of Vc of t for t greater than 0. Whatever I have discussed previously in the same discussion is here. The final expression here is Vc of t is equal to 10 plus 30 into e raised to the power of minus t by tau, which is 80 into 10 raised to the power of minus 3. Now here we will calculate Vc of t at t is equal to 0 as well as at t is equal to infinity. If we are finding at t is equal to 0, this Vc of t is equal to, this t will be 0, means e raised to the power of 0 is 1. 1 into 30 will be 30. 30 plus this 10 will be the 40. This 10 plus 30 will be the 40. That is voltage across the capacitor at this instant, that is t is equal to 0, is the 40 volt. Similarly, whenever we are substituting this value of t as infinity, e raised to the power of minus infinity, which is 0, 0 into this 30 will be 0, and this voltage across capacitor will be the 10 volt. Means at t is equal to infinity, the voltage across capacitor will be the 10 volt. Means indirectly, as the time progresses, the voltage across the capacitor will decrease and it will reach to the minimum value, which is nothing but the 10 volt as per this particular expression, that is Vc of t is equal to 10 plus 30 into e raised to the power of minus t by tau. That is the case. Finally here, in this particular case, the third point is expression for the current flowing through the capacitor as well as expression for the voltage. Always the current flowing through the capacitor is given by expression C into dVc of t upon dt. C is the constant, which is 2 into 10 raised to the power of minus 3, and d by dt of Vc of t is nothing but already we have derived an expression which is 10 plus 30 into e raised to the power of minus t by tau. In that particular case, if we are differentiating this equation with respect to t, this is the constant, then the differentiation of this constant term is a 30. This constant, it is as it is. Differentiation of e raised to the power of minus t by tau will be minus 1 upon tau, that is minus 1 upon 80 into 10 raised to the power of minus 3 into e raised to the power of minus t by tau. And if we are simplifying this expression further, we will get the final expression as IC of t, that is current flowing through the capacitor, is equal to, it is minus 75 into e raised to the power of minus t by tau is the expression for the current flowing through the capacitor. Finally, expression for voltage across capacitor, the general expression is R into I of t. Here R is the resistance, which is 40, and I of t, the current flowing through the circuit, is minus 0.75 into e raised to the power of minus t by tau. If we are simplifying this, finally the voltage across resistance will be minus 30 into e raised to the power of minus t by tau. Now here in this case, we have to note about the 2 points. What are the 2 points? In this case, 2 points are why this value is a minus and why this particular voltage is minus. Now here we will discuss that. In this case, before switching, the current flowing through the capacitor is something like this, or current flowing through the circuit is something like this. In that particular case, the voltage across capacitor has polarity something like this, and voltage across the resistor has the polarity something like this. This is before switching, and the voltage across capacitor is reached to its maximum value, which is nothing but the 40. Similarly, whenever the switch was shifted in the position number 2, in that particular case, this voltage is the 10 volt and the voltage across capacitor is the 40 volt. Means this voltage is higher than the voltage available across the source. That's why this source is acting as a main delivering component, and it will start the actual direction of the current in this particular case will be anticlockwise, something like this. In that particular case, this will act as a positive term and this is acting as a negative terminal. And this direction of the current after switching is reverse as that of the original direction of the current. That's why this value is negative. And finally, Look at the polarities of the voltage developed across resistors. The previous polarity and the current polarity, that is polarity voltage across resistance, is different or reverse after switching. That's why this value is coming to be negative. That's all about this video. Thank you for watching this video. Thanks a lot.